Hello students, today I am going to discuss the physics paper of NEET 2018. Okay, first question is current sensitivity of a moving coil galvanometer is 5 division per milliampere and its voltage sensitivity is 20 division per volt. The resistance of the galvanometer is. So in this question you have to calculate resistance. We know that resistance from Ohm's law is equal to what? V upon I. Here in this question, the information given is, first is current sensitivity. Current sensitivity means what? How much current is flowing what is the deflection in the galvanometer when unit current is flowing. Clear? So it is given as 5 division per milliampere. Okay. Next thing given is voltage sensitivity. Voltage sensitivity means what? That whenever the voltage is given, then what is the deflection? Whenever we are putting some voltage across a moving coil galvanometer, then what is its deflection? Okay. Moving coil galvanometer is like this, and whenever some current flows, it deflects because of torque which is acting on this needle. Clear? Okay, so this is given as what? 20 division per volt. Okay, here you have to calculate what? Resistance. And these two quantity are given. Then what you can do, that resistance is equal to, you can say that this is nothing but theta upon I divided by theta upon V. If you are dividing this current sensitivity with this voltage sensitivity, then what you will get? These two quantity will get cancelled out, and here this is what? V upon I. So just put the value. It is given as 5 division per milliampere. So 5 division per milliampere. So you can write this one as, this is 5 into 10 raised to power 3. Why this is 10 to the power 3? Because it is given as milliampere. So when here current is in denominator, when it will come up, it will become 5 into 10 raised to power 3. Next is voltage sensitivity. It is given as what? 20. So here you will get 500 divided by 20. This 2 can cancel out and answer is your 250. So answer for first question is what? 250 ohm, and this is your first option. Now the second question is, a metallic rod of mass per unit length 0.5 kg per meter is lying horizontally on a smooth inclined plane which makes an angle of 30 degree with the horizontal. The rod is not allowed to slide down by flowing a current through it. When a magnetic field of induction 0.25 Tesla is acting on it in the vertical direction, the current flowing in the rod to keep it stationary is. Okay, see here in this question there is one rod, metallic rod is here. Suppose that there is rod and that rod is inside this plane, and its mass per unit length m upon L. It is given as, mass per unit length is given as what? 0.5 kg per meter. Clear? Now what will happen? One mg will act here on this mass in vertically downward direction. Next, okay, first thing is what? Whenever a rod is kept on inclined plane, this rod will slide down. It will slide down. Why? Because this mg has two components. One is mg sine theta and one is what, mg cos theta. Here theta is 30 degrees, so I am writing this one as 30 degree and this one also as 30 degree. So what is happening now, one component of this mg is in this direction, mg cos 30, and here one component is what, mg sin 30. Now by like whatever the initial data which is given here, according to that what you can say that this conductor has tendency to comes down, it has tendency to come down. Now what they are saying, the rod is not allowed to slide down by flowing a current through it when a magnetic field induction of 0.25 Tesla is acting on it in vertical direction. Okay, one magnetic field B is acting here in this direction. So what you can say that due to this B, one force, magnetic force will act here, FB. Due to this magnetic field B in this direction, in vertically upward direction, one FB will act in this direction, in horizontal direction. Now this FB has, you can say that it will have two component. One is what, FB cos 30 degree. Why this is, because this is 30, this is also 30 degree. So FB cos 30 degree, and one another here also FB sin 30 degree. Clear? Now if this object is not, if this rod is not sliding, then what you can say that this component, not FB, this component FB cos 30 is equal to mg sin 30. So FB is equal to what, ILB cos 30 is equal to mg sin 30 degree. So from here you have to calculate what, current, how much current is flowing. I will be equal to m upon L, G sin 30 upon cos 30 is what, tan 30 divided by B. M upon L value is given, this is your mu, so it is 0.5. G is, you can take this one as 10, tan 30 means 1 upon root 3, and B is how much given in this question? B is given as 0.25. Clear? Now just solve this one. You can say that 0.5, when you will solve this one you will get 20 by root 3. Clear? On solving this one you will get answer as what, 11.32. Clear? So you will get what, 11.32 ampere, which is the answer for second question, and this is your third option. Next is third question. An inductor 20 millihenry, a capacitor 100 microfarad and a resistor 50 ohm are connected in series across a source of EMF. V is given as 10 sin 314t. Here that inductance is given as 20 millihenry, capacitance is given as 100 microfarad. Okay, from here you can say that omega is also what, angular frequency is 314. Okay, now you have to calculate here power loss. Power loss is equal to, then its formula is what, Vrms into IRMS multiplied by cos, where this is what, your power factor. Or you can also say then this one is what, 1 by 2 V naught into I naught into cos phi. Clear? Okay, here volt V is given, so what you can say that 1 by 2 I can be written as what, V naught, I can be written as V naught upon Z. Cos phi you can also write this one as R upon Z. Clear? Power factor means only that real part. Real part means what? That resistor part. So R upon Z. Now this value you can write this one as 1 upon 2 V naught square by Z square into R. Clear? So this is your what? Power loss. Now you have to just put the values. First calculate Z. Z can be written as what? You can write this Z as root under XC minus XL whole square plus R square. XC is your 1 upon omega C. Omega is 314. This is 100 microfarad. So you can write this one as, if it is 100 microfarad, you can say that this is nothing but 10 raised to power minus 4 farad. Clear? So this will become 314 into 10 raised to power minus 4 minus omega L. Omega here is 314 and L is given as what? 20 millihenry. Millihenry means what? 20 into 10 raised to power minus 3. This is your whole square plus R square. Resistance here in this case is 50 square. So on solving this one, you will get as 56 ohm. Just solve this value, you will get answer as what? 56 ohm. Approximately you can say that this is what? 56 ohm. Next is what? This power loss. So now just put the value P is equal to 1 by 2 into V naught. V naught square means 10 square means 100. Z square. Z square means 56 square. Means 56 into 56 multiplied by R. Resistance is given as 50. So this one will become what? 50. And on solving this one, you will get value as 0.79 watt. So this is your answer for third question, which is option 2. 0.79 watt is your answer for third question. Thin diamagnetic rod is placed vertically between the poles of an electromagnet. When the current in the electromagnet is switched on, then the diamagnetic rod is pushed up out of the horizontal magnetic field. Hence the rod gains gravitational potential energy. The work required to do this comes from. Okay, there is one diamagnetic rod which is kept in between what? An electromagnet. Let's suppose that this is one material, diamagnetic material. Okay, for diamagnetic material there is one property that the diamagnetic material always, whenever there is magnetic field, the diamagnetic material will always move from high magnetic field region to the low magnetic field region. Like simply like repulsion. Clear? Like how positive charge and positive charge repels each other. Na? So what happens that you will say that the positive charge will move from, if it is going away from that another positive charge, or if there is two magnets, then south pole and south pole repels each other. So what you can say that south pole is going from higher magnetic field towards lower magnetic field. Clear? So same thing here also happening. That's why diamagnetic material is moving up. So what is the main source? What is the main reason which they are asking that the work required to this comes from? So from where that work is done? Who is doing that work? So that work is done by your electric current. Why? Because that magnetic field. What is the source of magnetic field? Source of magnetic field is what? Electric current. So in this question, that work done, the required work done is because of that current source. So option second is the correct answer, the current source. So for fourth, answer is 2. The refractive index of the material of a prism is root 2 and the angle of prism is 30 degree. One of the two refracting surface of the prism is made of a mirror inward by silver coating. A beam of monochromatic light entering the prism from the other face will retrace its path if its angle of incidence on the prism is. Okay, just see here what is happening. There is one prism, clear, and one of its surface is silver coated, clear. So now what will happen, that when light is entering here, so from this surface there will be refraction, and because here it is mirror, it will again reflect back. Instead of emerging from this surface, it will simply reflect back, clear. So what they are saying, that for what they are asking, that for what angle of incidence, after reflection this ray will retrace its path, means simply it will come back, it will just follow the path, or it will just follow that initial path, clear. Here it is given angle of that prism is 30 degree and refractive index is given as √2. Okay, so this question is simple, just you have to think a little bit that what is the condition for that retracing of path. Okay, so we know that in case of mirror, whenever angle of incidence or that incident ray is, whenever incident ray is perpendicular to that mirror, then it will bounce back, it will retrace its path. So here also, if this ray is perpendicular to this mirror surface, then what will happen? It will simply retrace its path, clear. So what you can say, that here this is what, 90 degree. So if this ray is perpendicular, in that case what will happen? It will retrace its path. So if this angle is 90 degree, this angle is what? 90 degree. This angle is 30 degree. So you can say that this angle is 60 degree. If this is 60 degree, this is your normal. This is what? Your normal. So if this is 60 degree, you can say that this angle is 30 degree. Clear? Okay. So when this angle is 30 degree, you have to find this I. So use Snell's law. By Snell's law, what you can say, that sin I upon sin R is equal to refractive index of that prism. So sin I is equal to refractive index into sin R. Mu is given as √2 into sin R. Sin, this is your R. So sin R is sin 30 degree, sin 30. So sin 30 is your √2, sorry, sin 30 is 1 by 2. This will become √2. So sin I is equal to 1 upon √2. So I will be equal to 45. This is your answer for this question. So correct answer is D for fifth one. Now the next question, sixth. An EM wave is propagating in a medium with a velocity v is equal to vi cap. The instantaneous oscillating electric field of this EM wave is along y-axis. The direction of the oscillating magnetic field of the EM wave will be along. Okay. See, in this question, question number 6, what it is saying, that direction of propagation is what? Positive x-axis. Clear? Okay. And electric field E is along your positive y-axis. Clear? So electric field is oscillating along positive y-axis and that wave is propagating along positive x-axis. Then we know one thing, that direction of propagation, how to find the direction of propagation? Simply cross product of E cross B. That cross product of E and B will give you what? the direction of this one, this cross product is what? Direction of propagation. So here direction of propagation is given along which axis? X axis. It is along x, and the electric field is along what? This is along y, or if I am writing this y as what? In terms of unit vector, so y I can write this one as j cap cross, we don't know what is this one, but we know this one x is what? I cap. So direction of propagation is along I, oscillation is along j, so you can say that j cross which unit vector will give you I. So simple that rule, that j cross k will give you what? I cap. Clear? So correct answer is what? K cap means what? It is oscillating along positive z direction. If you will say here as minus k, like see, suppose here if it is question, if it is minus I, which means what? Here it will be minus k. Why? Because j cross k is plus, j cross minus k will give you what? Minus I. So here, but in this question, direction of propagation is along positive x direction. So oscillation of magnetic field is along that positive z direction. So correct answer is fourth. Next question. An object is placed at a distance of 40 centimeter from a concave mirror of focal length 15 centimeter. If the object is displaced through a distance of 20 centimeter towards the mirror, the displacement of the image will be. Okay, there is one concave mirror here. This is your concave mirror. Clear? Focal length is given as 15 centimeter. Clear? Object, initially that object is at 40 centimeter. 40 centimeter. So you can say that U is minus 40 because this is concave mirror. F is minus 15. So V you can say that using that mirror formula, V is equal to UF upon U minus F. So you will get this value as 15 into this 600 U minus F means minus 40 minus plus 50. Sorry, not 50, it is 15. So 600 by this value is minus 25. So minus 25 means minus 24. Clear? So this is your what? Initial position. Next, when this object is displaced and it is now at, it is displaced by 20 centimeter. Now this is new position. I can write this one as U dash. So if U dash is equal to 20 centimeter displaced, which means what? Now this distance is what? 20 left. So U dash is also 20, and this is what? 20 centimeter, and this is also your 20 centimeter. It is displaced by 20 centimeter towards the mirror. So new U is what? Object distance is what? That 20. Next, so V dash will be equal to what? U dash into F by U dash minus F. So here you can say that 20 into 15. This value is minus 300 divided by U minus F. U minus F means what? Minus 5. Okay. Okay, this is not minus 300. Okay, so this value is what? 60. So you can say that next V dash is what? V dash is equal to minus 60. Okay, so displacement will be equal to how much it is, image is displaced. So I am writing this one as delta V is equal to V dash minus V. V dash is minus 60, minus V means how much? This is 24, minus minus it will become plus 24. So this answer is minus 36 centimeter. So displacement is what? Minus 36 centimeter. Now how to find whether it is moving towards the mirror or away from the mirror? Okay, by sign convention we know that if your answer is coming as negative, negative means what? It is moving away from the pole. Clear? If your answer is positive, which means it is moving towards the pole, or in terms of incident ray, actually whatever that direction, sign convention, we can use the sign of direction of incident ray. So here this answer is what? Negative. Negative means what? It is moving away from the pole. Clear? Okay, so answer is minus 36 centimeter, or simply you can say that 36 centimeter away from the mirror. Okay, next question, question number 8. The magnetic potential energy stored in a certain inductor is 25 millijoule. When the current in the inductor is 60 milliampere, this inductor is of inductance. Okay, see here, this question is direct because we know that energy stored in a inductor is what? Half Li square. Clear? And they are asking inductance. Inductance means they are asking value of L. L is equal to 2E upon I square. Value 2E is how much given? 25 millijoule means 25 into 10 raised to power minus 3. I square 60 milliampere is given. So 60 into 60, that is 3600 into 10 raised to power minus 6. Solve this one. To power 3. Okay, now after solving this one is 25 into 250, 500 by 36. When you will solve this one, you will get your answer as 13.89 Henry. So which is your third option? 13.89 Henry. Question number 9. An electron of mass m with an initial velocity v is equal to v naught I cap enters an electric field E is equal to minus E naught I cap, where E naught is constant at t is equal to 0. If lambda naught is its de Broglie's wavelength, then its de Broglie wavelength at the time t is. Okay. See here, we know one thing, that de Broglie wavelength lambda will be equal to h upon mv. Clear? And it is given that lambda naught is its de Broglie wavelength, so you can say that this lambda naught will be equal to h upon mv naught. Clear? Next, where v is what? Velocity of that object or any particle. It is saying that initial velocity of an electron is given as what? V is equal to V naught I cap, and an electric field E is given as, electric field is in the direction of what? That velocity only. So due to this electric field, a force, this is given as minus E naught I cap, because this is electron. So electron will move in opposite direction to that of electric field. So what you can say, F will be equal to what? With sign you can say that it will be E into E, because minus E naught, and for that electron, so you will get F is equal to E I cap. Clear? Acceleration is equal to force upon mass, so E by m. Okay, once acceleration is known, at time t, v will be equal to, we know that v is equal to u plus at, so it will be equal to v naught plus t by m. Clear? This is your v, and lambda is equal to, we know that h upon mv, so lambda will be equal to h upon m, v is this value. If you are taking v naught constant, common, then it will be e by m v naught t. This h upon m v naught value, this is what? This is your lambda naught. So you can say that this is lambda naught 1 plus e by mv naught t. Clear? So correct answer here is option second. Question number 10. When the light of frequency 2v0, where v0 is threshold frequency, is incident on a metal plate, the maximum velocity of the electrons emitted is v1. When the frequency of the incident radiation is increased to 5v0, the maximum velocity of electron emitted from the same plate is v2. The ratio of v1 and v2. Okay, this question is from photoelectric effect. We know one thing, that velocity related with what? That kinetic energy. So maximum kinetic energy is equal to what? It is your h nu minus work function phi. So you can say that maximum kinetic energy means 1 by 2 m v max, or I am saying this one as what? v1 square is equal to, initially it is how much? That frequency is 2 h nu naught minus, and threshold frequency is given as what? Nu naught. So it will be equal to h nu naught. Clear? So this is your first case. So here you can say that half m v1 square is equal to h. This is your maximum kinetic energy. So you can say that this is your first equation. Similarly, in second equation, this value, this term will become what? 5h nu naught minus h nu naught, because that threshold frequency is same for both cases. So that work function will always remain same. So here this value is what? 4h nu naught. So you can say that half m v2 square is equal to 4h nu naught. You have to take the ratio of these two. Ratio means what? v1 square by v2 square is equal to 1 by 4. So v1 upon v2 will be equal to 1 by 2. So ratio of their maximum velocity is what? 1 by 2 means second option. Question number 11. For a radioactive material, half-life is 10 minutes. If initially there are 600 number of nuclei, the time taken for the disintegration of 450 nuclei is, okay, here what is given? T half. T half is what? How much? 10 minutes. Next, initial value is how much? Initially it is 600. Clear? Now they are asking the time taken for the disintegration of 450 nuclei. Okay, so if 450 is disintegrated, which means now final how much nuclei is left? 150 only. Final number of nuclei is what? 150. So actually there is two methods to solve this one. One is what? Like by seeing this generally, what you can say that finally how much, what is the number of nuclei left? 150. Initially it was 600. Clear? And half-life is 10. So what you can say that after 10 minutes number of nuclei left is 300. Then at t is equal to 10, number of nuclei is what? 300. At t is equal to 20, another half. How much left is nuclei? 150 nuclei is left, and 150 is what? That final nuclei, na? What which they are asking. So in this question you can directly say that answer is what? 20 minutes. Why? Because half-life is 10 minutes. So after 10 minutes, this number of nuclei is 600. So what is the amount of nuclei left after 10 minutes? 300. Then again after another 10 minutes, the number of nuclei left is what? Half of that 300, which means 150 only. So it will take 150, it will take 20 minutes for the disintegration of what? How many nuclei? 450 nuclei. So here you can directly say that answer is what? 20 minutes. Next, question number 12. The ratio of kinetic energy to the total energy of an electron in a Bohr orbit of the hydrogen atom is? Okay. See here, the ratio of kinetic energy to the total energy. Total energy is equal to 1 by 2 of potential energy of an electron is equal to minus of kinetic energy. Clear? So you can directly say here what? That if total energy is if kinetic energy is x, then total energy is what? Minus x. So their ratio of the total energy by kinetic energy is they are asking ratio of kinetic energy to the total energy is equal to what? X upon minus x. So this is equal to what? 1 upon minus 1. So ratio is 1 is to minus 1. So your answer is fourth option. Okay. Question number 13. Unpolarized light is incident from air on a plane surface of material of refractive index mu. At a particular angle of incidence I, it is found that the reflected and refracted rays are perpendicular to each other. Which of the following option is correct for this situation? Okay. Whenever any unpolarized light is incidenting on a surface, this is your surface, clear? One is reflected and this is your reflected and this is your that refracted. These are perpendicular, clear? So here in this case it is unpolarized light. This is unpolarized light. This is partially polarized and this is polarized, clear? Okay, here in this case that polarized light is perpendicular to the plane of the incident. In this case that reflected ray is perpendicular to the plane of that incidence. So you can directly say, this is direct question, correct answer is fourth one. Reflected light is polarized with its electric vector perpendicular to the plane of incidence. Here this electric vector is perpendicular to the plane of incidence. So this is just a direct question. In Young's double slit experiment, the separation D between the slits is 2 millimeter. The wavelength lambda of the light used is 5896 angstrom and distance D between the screen and the slits is 100 centimeter. It is found that angular width of the fringe is 0.20 degree. To increase the fringe width to 0.21 degree, the separation between the slits needs to be changed to. Okay. See that theta is equal to lambda by d. Clear? And you can say that theta is inversely proportional to this d because lambda is same. So you can directly say that theta is inversely proportional to what? D. Okay. So here two widths are given, two angular widths are given. So you can say that theta 1 by theta 2 will be equal to what? D2 by D1. Initially how much it is given? Slits is 2 millimeter. 2 millimeter and D2. Theta 1 is what? 0.20 by 0.21. Okay, so you can say that D2 will be equal to 0.20 into 2 by 0.21. Remove this one, remove this one. So it is what? 40 by 21. Solve this one, you will get value as 1.9 millimeter. So correct option is fourth one. An astronomical refracting telescope will have large angular magnification and high angular resolution when it has an objective lens of, okay. For first they are asking for large angular magnification. For large angular magnification, its focal length should be large, clear, that is directly proportional to its focal length. And for angular resolution, its diameter of that lens, that should be large. So here you can say that because we are increasing both things, we have to increase that angular magnification and we want high angular resolution. So for both cases, focal length should be large and that's its diameter should be large. So correct answer is first option. The power radiated by a black body is P and it radiates maximum energy at wavelength lambda naught. If the temperature of the black body is now changed so that it radiates maximum energy at wavelength 3/4 lambda naught, the power radiated by it becomes Np. The value of N is, okay, just here we know that power is directly proportional to T raised to power 4, clear. And from Wien's displacement law, we can say that T is inversely proportional to lambda m, that maximum wavelength, clear. So from here what you can say, that P1 upon P2 is equal to lambda m2 by lambda m1 raised to power 4. So P1 upon P2 is equal to, okay, initially it is lambda naught and finally it is 3/4 lambda naught raised to power 4. So P1 upon P2 is given as P and Np naught is equal to, when you will 3 raised to power 4 means it is 81 by 256 and 1 by n is equal to 81 by 256. So n will be equal to 256 by 81. So this is your correct, which option? Option number 1. Two wires are made of the same material and have the same volume. The first wire has cross-sectional area A and the second wire has cross-sectional area 3A. If the length of the first wire is increased by delta L on applying a force F, how much force is needed to stretch the second wire by the same amount? Okay, see, there are two wires, A1 is given as A, so here A2 is equal to, it is given as 3A. L1, length L1 is given as, suppose if it is L, L2 will be L by 3. Why this is? Because volume is constant. When you will multiply these two, you will get same volume. Okay. Next is what? We know that delta L, I can say that delta L1 is equal to F upon A1, F1 upon A1 into L1 Young modulus. Clear? Here similarly you can see that if you are putting all the value, then delta L1 is equal to, F1 is what? That force is F, so this is F into L1 is your L, A1 is A, this is gamma. Similarly delta L2 will be equal to F2, we have to calculate that F2 only, L2 is what? L by 3 divided by A2 is 3A into gamma. Clear? If these two quantity are same, then what you can say, that F2 L by 9A y young modulus is equal to F1 is your F into L A y. This quantity cancel out, so F2 is equal to 9F. This is your answer. Okay, so correct option is 9F, second option. Question number 18. A small sphere of radius r falls from the rest in a viscous liquid. As a result, heat is produced due to viscous force. The rate of production of heat when the sphere attains its terminal velocity is proportional to. Okay, you can say that dq by dt is proportional to viscous force into its Vt. Clear? And Fv is equal to, directly you can say that Fv is proportional to R into Vt. Clear? So you can write here that this is proportional to R Vt square, and we know that Vt terminal velocity is proportional to R square. When we are calculating that, you will get one term R square. So you can say that dq by dt is proportional to R into R square whole square. So dq by dt is proportional to R raised to power 5. So correct answer is first option for question number 18. A sample of 0.1 gram of water at 100 degrees Celsius and normal pressure requires 54 calorie of heat energy to convert to steam at 100 degrees Celsius. If the volume of the steam produced is 167.2 cc, the change in internal energy of the sample is. Okay. See here, change in internal energy, delta U is equal to what? Delta Q minus delta W. Clear? So first calculate delta Q. Delta Q is given as how much? 54 calorie. So 54 into 4.2. 54 into 4.2, you will get you will get 226.8 joule, because this value is given in calorie. First you have to convert that into joule. Next is work done. Work done is equal to what? P delta V. Pressure is given as 1.013 into 10 raised to power 5, and delta V is equal to what? 167.1 cc. Cubic centimeter is what? Cubic centimeter you will get 10 raised to power minus 6 cubic meter. You can take some approximation, and then what you will get? 16.7. You can say that this value is approximately equal to what? 16.7 joule. So now just subtract these two. Delta U will be what? 226.8 minus 16.7. You will get this value are 210. See here, we did one approximation here in this multiplication, so you will get values slightly less than 210. So you can see that fourth option is what? 208.7. So correct option is what? Fourth one. See question number 20. The kinetic energy of a planet in an elliptical orbit about the sun at position A, B and C are Ka, Kb and Kc. AC is the major axis and SB is perpendicular to AC at the position of the sun as shown in the figure then. Okay, see here in this question number 20, a planet is moving in an elliptical orbit, and this is your sun S, A, B and C, it is given. This is your S. Okay. What they are asking, the kinetic energy of a planet in elliptical orbit about the sun at position A, Ka, Kb and Kc. They are asking relation between Ka, Kb and Kc. Okay, see here, in this case, what is relation of kinetic energy? First thing what you can say, that this is revolving around sun, so angular momentum L is conserved, angular momentum is conserved, clear? And if L is conserved, what you can say, that kinetic energy relation in terms of L is what? L square by 2I. So you can say that if this value is constant, this value is always constant, then you can say that K, that kinetic energy, is inversely proportional to I, where I is what? Moment of inertia. So moment of inertia, if value of I is greater, in that case kinetic energy will be what? Lesser, and if value of I is less, in that case kinetic energy will be more. So you can say that this point is nearest to that sun, clear? And as it is going here, after that this position, and C is farthest from this sun. So what you can say, that IC greater than IB greater than IA, clear? IA is less than IB and IB is less than IC. So if this is inversely proportional, you can say that kinetic energy at A is maximum, kinetic energy at B, and after that kinetic energy at C. So which option? This is your fourth option, relation between kinetic energy of planet when it is revolving around sun.